Welcome to Module 1 of 5, Foundations, where we will cover Engelmann's life and Bloom's 2 sigma problem. This module spans slides 1 to 55. The entire training is about the science of mastery, how Siegfried Engelmann, Benjamin Bloom, and direct instruction can transform American education. This full training includes 4 modules. Module 1, Foundations, is slides 1 through 55. Module 2 covers the evidence, Module 3 covers the science, and Module 4 covers the modern context. Module 1 is divided into 2 sections. Section 1, The Man from Chicago, covering slides 3 through 30, and Section 2, Bloom's 2 sigma problem, covering slides 31 through 55. We begin with Section 1, The Man from Chicago, focusing on Siegfried Engelmann's life and legacy across slides 3 through 30. Engelmann grew up in a rough section of Chicago, working at an Ingersoll steel plant at age 15. It was there that his co-worker, Joshua Baker, taught him how to think straight. Engelmann credits Joshua Baker as the person who influenced him most, teaching him how to think straight and solve difficult problems. He was an unlikely scholar, failing algebra in junior high, proud of not reading in high school, and known to steal exams. Yet he knew he was a fraud inside. Engelmann was a fighter, a teacher, and a seeker. He was a heavyweight boxing tournament runner-up, a football player, and initially believed he was, quote, made to be a blue-collar worker. While at the factory job, he decided to, quote, get smart and read the whole dictionary. This effort resulted in him knowing tens of thousands of words. A question from a candy company president led to the, quote, candy bar that changed education. Engelmann became enthralled by the question, how can we help the mind learn? In 1964, direct instruction was born. A summer experiment showed disadvantaged 4-year-olds increasing their IQs from 96 to 121 in 1 year, learning to read and do second-grade math. Noel Pearson lauded Engelmann, calling him the quote, 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 among 20th century educational theorists, and his theory of instruction, the educational equivalent of Newton's Principia Mathematica. Engelmann made several groundbreaking discoveries first, including phonemic awareness, the language gap, pioneering modern cognitive psychology, and anticipating RTI by 50 years. The motto that defined Engelmann's 50-year career was, if the student hasn't learned, the teacher hasn't taught. The central question when designing programs is, what idea explains the biggest chunk of content possible? This organizes the subject and reduces the memory load on the student. Engelmann, referred to as the writing machine, wrote for 6 hours a day for 50 years, authoring or co-authoring over 100 curricula. Each program took 3 to 10 years of field testing to develop. Engelmann's ironclad rule was, every student would learn everything in the program, and the average teacher would be able to teach it. No program was published without real-world field testing. Siegfried Engelmann stated in 2008 that, quote, time is the great enemy of the at-risk child. He emphasized reproducing the function of a middle-class upbringing, not just the form. Engelmann dedicated his life for the kids, always. He never gave up on a child and focused on ensuring that millions of poor children learned through his methods. We now transition to Section 2, Bloom's 2 sigma problem, covering the promise, evidence, and myth around this phenomenon across slides 31 through 55. Benjamin Samuel Bloom was born in Lansford, Pennsylvania in 1913. He was a voracious reader who earned his degrees from Penn State and his doctorate from the University of Chicago. At the University of Chicago in the 1940s, Bloom was influenced by the idea that education should be judged by what students learned, not what teachers taught, and that students learn best at their own pace. Bloom's 1968 paper, Learning for Mastery, posited that failure reflects poor teaching, not student incapacity. Given enough time and feedback, virtually all students can master the material. John Carroll's 1963 model of school learning provided the key insight. Degree of learning equals time spent divided by time needed. Aptitude was redefined as the time needed to learn, not a fixed capacity. Bloom famously stated in 1968 that one can regard as unsuccessful any educational effort which approximates the normal distribution. He argued for varying time, not mastery. 2 dissertation studies by Bloom's students compared conventional instruction, mastery learning, and one-on-one tutoring. The results showed tutored students significantly outperformed the conventional group. The 2 sigma effect, showed that tutoring plus mastery instruction resulted in a 2.0 standard deviation gain over conventional teaching. This meant the average tutored student performed at the 98th percentile. Bloom challenged the field to find, quote, methods of group instruction as effective as tutoring. He suggested that combinations of alterable variables could reproduce the tutoring effect. Despite the dramatic findings, these studies had limitations: small samples, extensive retesting for tutored students, and non-standardized assessments. Bloom did not acknowledge these problems. Later meta-analyses, like those conducted by Robert Slavin, found that of hundreds of mastery learning papers, only 7 met basic standards. The median effect size in rigorous studies was approximately 0, with a maximum of 0.25 standard deviations, far from Bloom's 1.0 or 2.0 claims. A 2 sigma feature analysis stated, Bloom offered the comforting fiction that brilliant methods could substitute for resources. 40 years later, we're still searching for the trick that will let us educate on the cheap. There is no trick. Despite the lack of substantiation for the 2 sigma effect, Bloom got key things right. Time should be the variable adjusted, not expected achievement, and far more children could achieve at high levels than typically do. The real answer to effective learning involves explicit instruction, extensive practice with feedback, a gradual increase in complexity, and regular formative assessment. There are no silver bullets or quick fixes. The Bloom paradox highlights that while his taxonomy and early childhood research justified programs like Head Start, his most cited finding was the least well substantiated. The investment paradox shows that we often invest the most in strategies that yield the least benefit, while high evidence approaches like mastery learning and direct instruction receive minimal policy investment.